if you're lucky enough to have a system of equations where one of each of the equations has a term that's the same but just opposite sign, there's a really quick and easy way of solving these to get a really fast answer. Now you can use substitution because certainly I can solve this equation so that it's, y equals something and then substitute for the y. But when something like this appears, it's as simple as drawing a straight line and adding. This is 4x. These add up to 0, and this equals minus 4. If I divide both sides by 4, I get x equals minus 1. And yes, it's that easy. So you would be able to solve this system of equations that fast. Take one of the two. I'll take the first one up here. So if I have 3 times x and x is minus 1 plus y equals 1, and I have minus 3 plus y equals 1. If I add 3 to both sides, and get y equals 4. So this system of equations, these are going to touch in one point. The x is minus 1 and the y is 4. So here's another example. And over here, the x's are not the opposite sign. You could change it by multiplying straight through by a negative, and then you would have a minus x. But we already have a situation where the system of equations is presented with these y terms being opposite signs. So let's just go ahead and solve it the simple way. We have 2x. These are a 0 pair. And minus 2 plus 16 is 14. I divide both sides by 2. And x equals 7. Once I have x equals 7, I just go back and I'm now going to plug that into one of the two equations. So x is 7, so I'm going to put 7 plus 3y equals minus 2. I'm then going to subtract 7 from both sides. And I get 3y equals minus 9. So y equals minus 3. So this system of equations is going to be x is 7 and y is minus 3. In this third example, I'm looking here, and this is not simple enough that I would want to do this with substitution because I would have to have either the x or the y already by itself, and I don't want to solve one of these two in order to find x or y. The simpler way would be to use elimination. But then again, looking at this, I don't have any two terms that readily are going to add up to 0. Looking at this first term, this can be converted into being a plus 6x. If I was to multiply straight through all of the terms by minus 3, I would then get positive 6x plus 12y equals minus 42. Now, looking at this line, if I was to add them, these would be a 0 pair. Then I would get plus 17y equals, and then is minus 17. And then if I divide both sides by 17, I get that y equals minus 1. Now taking this equation over here, I have minus 6x plus 5 times y, which is minus 1, equals 25. Simplifying, I have minus 6x minus 5 equals 25. And I get minus 6x, 0 pair, 30. If I divide both sides by minus 6, I get that x equals minus 5. So this system of equations solves to be minus 5, minus 1, and it meets in a single point. In this final example, the system of equations, they have the same x terms and the same y terms. If I was to multiply straight through by -1 here, I would have 3x minus y equals +3. And if I was to add these two would add up to 0, these two would add up to 0, and I would get 0 on this side and 2 on this side. And it doesn't work because if you take a closer look at these two equations, what you really have, I'm going to rewrite this one as y equals 3x minus 1 and y equals 3x minus 3. Let's look at this on a graph. Looking at equation 1, the y-intercept is -1, and it goes up 3 over 1, up 3 over 1. And if I draw that, and then compare it to this other one, has a y-intercept of -3, goes up 3 over 1, up 3 over 1. And these two lines have the same slope, but different y-intercepts. And that means that they're parallel, but they'll never touch. So solving a system of linear equations is looking for the point where they touch each other. And there are no points, there are no x's and y's where these two lines share the same point. By contrast with the last example, if I was to multiply this one here, this line by 3, I would get 3x plus 6y equals 18. And you notice they're the exact same line. So if I was to graph those, I'll change one of these into the y equals mx plus b form. So I would have 6y equals minus 3x plus 18, dividing each term by 6. I would get y equals minus 1/2 plus 3. Both of these lines are plus 3, and I go up 1 over 2, up 1 over 2. That would be line 1, and line 2, I'll draw it next to it, but the idea here is the two lines would be right on top of each other, so they would have an infinite many solutions in common. And getting back to this over here, I'll multiply this one by -1. So I get minus 3x minus 6y equals minus 18. And now I'm comparing this line with this line. If I was to add them, I would get 0 on this side equals, and 18 minus 18 is 0. In contrast to the prior method, which had 0 equals -2, this one 0 equals 0 is infinitely many solutions. So when you see 0 equals 0, it's infinite. When you see something like this, there are no solutions. So this one's infinite, and this one is no solutions.
That was easy.